In computing, the same origin policy is an important concept in the web application security model. The policy permits scripts running on pages originating from the same site a combination of scheme, host name, and port number to access each other's DOM with no specific restrictions, but prevents access to DOM on different sites. The same origin policy also applies to XMLHttpRequest and to WebSocket. This mechanism bears a particular significance for modern web applications that extensively depend on HTTP cookies to maintain authenticated user sessions, as servers act based on the HTTP cookie information to reveal sensitive information or take state-changing actions. A strict separation between content provided by unrelated sites must be maintained on the client side to prevent the loss of data confidentiality or integrity. History. The concept of same origin policy dates back to Netscape Navigator 2 in 1995. All modern browsers implement some form of the cross-origin policy as it is an important security cornerstone. The policies are not required to match an exact specification but are often extended to define roughly compatible security boundaries for other web scripting languages, such as Adobe Flash or Adobe Acrobat, or for mechanisms other than direct DOM manipulation, such as XMLHttpRequest. Origin determination rules. The algorithm used to calculate the origin of a URI is specified in RFC 6454, Section 4. For absolute URIs, the origin is the triple protocol, host, port. If the URI does not use a hierarchical element as a naming authority or if the URI is not an absolute URI, then a globally unique identifier is used. Two resources are considered to be of the same origin if and only if all these values are exactly the same. To illustrate, the following table gives an overview of typical outcomes for checks against the URL http, www example compage HTML. Unlike other browsers, Internet Explorer does not include the port in the calculation of the origin, using the security zone in its place. Relaxing the same origin policy. In some circumstances the same origin policy is too restrictive, posing problems for large websites that use multiple subdomains. Here are 4 techniques for relaxing it. Document domain property. If 2 windows contain scripts that set domain to the same value, the same origin policy is relaxed for these 2 windows, and each window can interact with the other. For example, cooperating scripts in documents loaded from orders.example.com and catalog.example.com might set their document domain properties to away example, thereby making the documents appear to have the same origin and enabling each document to read properties of the other. This might not always work as the port stored in the internal representation can become marked as null. In other words, example.com port 80 will become example.com port null because we update document domain. Port null might not be treated as 80 and hence might fail or succeed depending on your browser. Cross-origin resource sharing. The second technique for relaxing the same origin policy is being standardized under the name cross-origin resource sharing. This draft standard extends HTTP with a new origin request header and a new access control allow origin response header. It allows servers to use a header to explicitly list origins that may request a file or to use a wildcard and allow a file to be requested by any site. Browsers such as Firefox 3.5 and Safari 4 use this new header to allow the cross-origin HTTP requests with XML HttpRequest that would otherwise have been forbidden by the same origin policy. Cross-document messaging. Another new technique, cross-document messaging allows a script from one page to pass textual messages to a script on another page regardless of the script origins. Calling the post-message method on a window object asynchronously fires an on-message event in that window, triggering any user-defined event handlers. A script in one page still cannot directly access methods or variables in the other page, but they can communicate safely through this message passing technique. JSONP. JSONP allows a page to receive JSON data from a different domain by adding a script element to the page which loads a JSON response from a different domain. Corner cases and exceptions. The behavior of same-origin checks and related mechanisms is not well defined in a number of corner cases, such as for pseudo-protocols that do not have a clearly defined hostname or port associated with their URLs. This historically caused a fair number of security problems, such as the generally undesirable ability of any locally stored HTML file to access all other files on the disk, or communicate with any site on the Internet. In addition, many legacy cross-domain operations predating JavaScript are not subjected to same-origin checks. One such example is the ability to include scripts across domains, or submit post forms. Lastly, certain types of attacks, such as DNS rebinding or server-side proxies, permit the hostname check to be partly subverted, and make it possible for rogue web pages to directly interact with sites through addresses other than their true, canonical origin. The impact of such attacks is limited to very specific scenarios, since the browser still believes that it is interacting with the attacker's site, and therefore does not disclose third-party cookies or other sensitive information to the attacker. Workarounds, to enable developers to, in a controlled manner, circumvent the same-origin policy. A number of hacks such as using the fragment identifier or the window name property have been used to pass data between documents residing in different domains. With the HTML5 standard, a method was formalized for this, the post message interface, which is only available on recent browsers. JSONP can also be used to enable AJAX-like calls to other domains. See also, cross-origin resource sharing, cross-site scripting, cross-site request forgery, cross-document messaging, references. External links, a detailed comparison of several flavors of same-origin policies, a review of deficiencies in same-origin policies and their implication for web security at the Wayback Machine, sample vendor-provided same-origin policy specification, the HTML5 specs definition of origin, WC3 article on the same-origin policy, RFC 6454 on the web origin concept.